Okay, good morning students. In the previous classes, we have discussed about the midpoint theorem, the converse of the midpoint theorem, and also I think we have discussed about the equal intercept theorem. So just today we will just review the equal intercept theorem and we will take up some problems based on equal intercept theorem. Obviously, midpoint theorem and the converse may be used somewhere or the other in while solving the problems on this particular concept. So let us review once again what is the equal intercept theorem. If a transversal makes equal intercepts on three or more parallel lines, then any other transversal cutting them will also make equal intercepts. Here we can see the three parallel lines L1, L2 and L3, and we have two transversals L4 and L5. The transversal L4 intersects the three parallel lines L1, L2, L3 and thereby cut off intercepts AB and BC. Now according to the equal intercept theorem, if the intercepts made by L4 on L1, L2, L3, that is AB and BC, if AB and BC are equal, that is AB equals to BC, then any other transversal like L5 in this case will also cut off equal intercept on the three parallel lines L1, L2 and L3. So that means if AB equals to BC, then PQ will also be equal to QR. This is the equal intercept theorem. If you draw any other parallel line, so that intercepts made by the transversal on these parallel lines will also be equal. So we have already known this particular fact, but again we will just try to prove this. To prove this, let us join A to R. This point, mark it as O. Now, in order to prove this equal intercept theorem, let us first look into the triangle ABO. So, in triangle ABO, we know that AB equals to BC. So, we have B is the midpoint of AC. This is the triangle ACR. Triangle ACR. In triangle ACR, B is the midpoint of AC. BO is parallel to CR, which is already known to us, it is given. So according to the converse of the midpoint theorem, if B is the midpoint and BO is parallel to CR, then O is the midpoint of the side AR. So we have, therefore, O is the midpoint of the side AR of the triangle ACR. Now we have proved that O is the midpoint of the side AR of the triangle ACR by the converse of the midpoint theorem. Now we will consider triangle APR. So in triangle APR, we have O is the midpoint of AR. O is the midpoint of AR. Just now we have proved above. Again, since L1 is parallel to L2, that means OQ is parallel to AP. OQ is parallel to AP. So therefore, since O is the midpoint of AR and OQ is parallel to AP, then Q is the midpoint of PR. Therefore, Q is the midpoint of PR. What does it mean? That means, therefore, PQ is equals to QR. This is also obtained by applying the converse of the midpoint theorem. So now that we have proved that PQ equals to QR under the given condition that AB equals to BC. So when AB equals to BC, that is the intercepts made by a transversal L4 on the three parallel lines L1, L2 and L3, we find that any other transversal like L5 also cuts off equal intercepts PQ and QR, which are also equal. So this is what is the equal intercept theorem. Now we will take a few questions based on this, and then the concept of the midpoint theorem, converse of midpoint theorem and this equal intercept theorem can be applied or may be applied in the same question as we have just now proved the equal intercept theorem. Now let us take the question number 1. In triangle ABC. D is D and E. D and E are 2 points on the side AB such that AD equals to DE and that's equals to EB. Through D and E, lines are drawn parallel. Lines are drawn parallel to BC, which meet the side AC. Meet the side AC at points F and G respectively. F and G respectively. Through F and G, lines are drawn parallel. Lines are drawn parallel to AB. Which meet the side BC at points M and N respectively. Prove that BM is equals to MN is equals to NC. So note down the question first, and now we will proceed to solve this particular question. The question says, in triangle ABC, D and E are 2 points on the side AB such that AD equals to DE equals to EB. Through D and E, lines are drawn parallel to BC, which meet the side AC at the points F and G respectively. Through F and G, lines are drawn parallel to AB, which meet the side BC at the points M and N respectively. So prove that BM equals to MN equals to NC. So if you have noted down the question, I will simply rub the board for the diagram. So it is given in triangle ABC. Let us draw the diagram. This is the diagram of the triangle ABC. This is A, B and C. D and E are 2 points in AB such that AD equals to D. So this is the point D and this is the point E. This is D and this is E. Through D and E are lines drawn parallel to BC. So let us draw lines parallel to BC. This one and this one. So these 3 lines are parallel, which meet the side AC at the points F and G respectively. Now through F and G, lines are drawn parallel to AB. So from M, we have to draw a line parallel to AB. So let us draw a line parallel to AB. So this line and this line are parallel, and also from G also we have to draw a line parallel to AB. So these 3 lines, and we mark it as M and N. So this is the question. We have to prove that BM equals to MN equals to CN. This part. We are given that D and E are the points on the side AB such that AD equals to DE equals to EB. So this part, this part and this part are equal as is given in the question. Now let us see to this triangle. In triangle AEG, we know that D is the midpoint of AE, E is the midpoint of DB, because all three parts are equal according to the question. So in triangle AEG, D is the midpoint of AE. Also we know that DF is parallel to EG. DF is parallel to EG. So here also we will be applying the converse of the midpoint theorem, that is, if D is the midpoint of the side AE of the triangle AEG and DF is parallel to EG, so F is the midpoint of AG. So therefore, F is the midpoint of AG. So now that we have got that F is the midpoint of AG, let us see to this equal intercept theorem here. Look at the lines DF, EG and BC. These three lines are parallel, and here it is given DE equals to EF. That means if you can take AB as the transversal, so this transversal AB cuts off intercepts DE and EB, which are equally length. Similarly, if you consider AC as the transversal for the same parallel lines DF, EG and BC, then we have FG equals to GC by the equal intercept theorem. So here, after applying the equal intercept theorem, we have FG equals to GC, and we prove that F is the midpoint of AG. So therefore, AF equals to FG, and that is equals to GC. We can write equal intercept theorem. So now we have proved that the parts AF, FG and GC are equal. Now we need to prove that BM, MN and NC are equal. Now let us see to the triangle FMC. So in triangle FMC, this triangle. Now G is the midpoint of FC. G is the midpoint of FC. And also you are given that GF, FM and AB are all parallel lines. So if G is the midpoint of FC and GN is parallel to FN, GN is parallel to FN, so we can say that N is the midpoint of CN. So therefore N is the midpoint of MC. Right? So N is the midpoint of, yeah.
So GN is parallel to FM.
FM, yes, FM. So GN is parallel to FM, so N is the midpoint of NC. Now you can see, so these three are parallel lines, and if these three are parallel lines, we know that this is a transversal. Consider these parallel lines GN, FM and AB. So this is the transversal, and we have AF equals to FG. So similarly, we can say that BM is equals to MN by the equal intercept theorem. So therefore, BM equals to MN is equals to NC by equal intercept theorem. So this proves our condition that BM equals to MN equals to NC. So in this triangle, G is the midpoint of FC, so and GN parallel to FM, so N is the midpoint of NC. So now that since AF equals to FG, which is the transversal for the three parallel lines GN, FM and AB, and since AF equals to FG, similarly BM will be equals to MN by the equal intercept theorem, and since N is the midpoint, so MN equals to NC, so therefore BM equals to MN equals to NC, and we have the condition proved here. So this is question number 1. Hopefully you have understood it. Note it down. We will move on to the next question, that is question number 2.
Wait.
Yeah. Diagram, hopefully you have done. Diagram?
Yes, sir.
Oh, okay, note it down.
Yes, sir.
Note it down. Once you finish, let me know.
Sir, written.
Done. Okay. Now let us move on to question number 2, which will be a simple question, and I think you will be able to answer the question. So question number 2. In the given figure, the lines L, M and N are parallel to each other. D is the midpoint of CE. D is the midpoint of CE. Find number 1, it is BC, part 2 is EF, part 3 CG, and part 4 is BD. So let us have the diagram first. So these are the 3 parallel lines given by L, M and N. This is C, A, B and C. This is the point D as is given. This is G, F and this is E. This part and this part is are given equal. The part AE is given as 12 centimeters. BA or AB is given as 6 centimeter. This part is AB is 6 centimeters. DF, this part DF is 4.2 and the GE, this part, this total part is given as 9 centimeters. GE is given as 9 centimeter, AB is 6 centimeter, DF is 4.2 centimeter, AE is 12 centimeter. We have to find BC. Now first of all, let us see that the lines L, M and N are parallel to each other. Also we can see that CE is a transversal to the set of parallel lines. To these parallel lines, CE is the transversal, and also at the same time CE cuts of equal intercept, because it is given CD equals to DE. Now if CE is the transversal and which cuts of equal intercepts CD and DE, then the other transversals also will cut off equal intercepts. That means this part and this part will also be equal, and this part and this part will also be equal. So this is by the equal intercept theorem we have achieved to this, reached to this particular result. Now let us start finding the values one by one. First part is BC. Now let us see where is BC. This is the part BC, and we have known by the equal intercept theorem that BC equals to AB. So BC is equals to AB, and the value of AB given is 6 centimeter. So this is equals to 6 centimeter. So the first part is done. Second part, EF. Now where is EF? This is EF, right? And this is EF, and we have been given GE as 9 centimeter. Now F is the midpoint by the equal intercept theorem, so EF will be half of GE. Half of GE, and that is will be half into 9, and that is 4.5 centimeters. So we have come across EF as well. Third point is CG. The third part is CG, which is CG. C and G. Okay, this is CG, this line. So if you have to look into this triangle CGE, D is the midpoint of CE, F is the midpoint of GE. So DF is parallel to CG and DF is half of CG. Or otherwise you can say CG is double of DF. So CG is twice of DF, and that is given as 4.2. So we have 8.4 centimeter is the value of CG. Hopefully you understood this by the application of the midpoint theorem. D is the midpoint of CE, F is the midpoint of GE, so DE is parallel to CG and DE is half of DF is half of CG, or CG we can say is double the length of DF. So CG is twice of DF, comes to 8.4. The fourth part, the last part, that is BD. Where is BD? So this is BD. Again in triangle CAE. CAE, B is the midpoint of the side CA, D is the midpoint of CE. So BD is parallel to AE and BD will be half of AE. So BD is half of AE and AE is given as 12 centimeters. So that comes to 6 centimeters. So all four we have found and we have applied here. Very first point we have applied here is the equal intercept theorem, because these two were equal given. So similarly this and this will become equal and this will become equal by the equal intercept theorem. And then we applied equal intercept theorem as well as the midpoint theorem to reach to the final results. So hopefully you have understood. And now moving on to question number 3. Note it down. Done? Can I rub the board?
Yes, sir. Yes, sir.
So,
Yes.
so let me write the question number 3. If you have not yet finished, you can carry on writing this part. So let me write the question number 3. In the given figure, PS is equal to 3RS. M is the midpoint of QR if TR is parallel to MN and MN is parallel to QP. Prove that part A is ST equals to 1 by 3 LS and part B RT is 1 by 4 PQ. So this is question number 3. Now let us see how can we solve this.
Excuse me, sir.
Yes, tell.
Sir, in exam diagram will become, or we have to draw it.
In case it is not given, you need to draw the diagram, but mostly you get a diagram. So here in the question it is mentioned in the given figure, so figure will be given. But if the figure is not that complex and it is easier to draw, then you have to draw it. So be prepared for everything and don't worry, with practice everything will become clear. So no need to panic. So let us draw the diagram first.
Sir, don't wait much, exam will start.
No idea, beta. Whenever I get an information, obviously it will be notified to you. Whatever information I get, I do share with you all. So let us wait for that particular time and then we'll be preparing like that. So let us at this moment just keep on preparing. If the exam dates comes out, so you should not be hanging around for completing the syllabus. So be up to date, and I think that will be an advantage for you. Anyway, so this is the triangle.
Okay.
This is PQ, and we have to extend this. This is drawn like this. Draw the diagram carefully. L. So given figure PS, and let me write down which is, this is the point S. Then we have this line, we have this line. So this is M, this is N, this is T, and this is R. So here is the diagram for you. Now let us use this diagram and find out how can you prove the part A and part B of this particular question. According to the question, PS equals to 3RS, first part is given. So given condition, let me write it down here. PS is equals to 3RS. M is the midpoint of QR. M is the midpoint of QR given. So QM equals to MR. So M is, okay, let us see to this triangle first. In triangle PQR, we have M as the midpoint of QR and MN parallel to PQ. We have been given TR parallel to MN and parallel to QP. That means these three are parallel to each other. So in triangle PQR, M is the midpoint of QR, M is the midpoint of QR, and also MN is parallel to PQ. MN is parallel to QP. So therefore we can say that N is the midpoint of PR. Therefore N is the midpoint of PR. And this is by the converse of the midpoint theorem. N is the midpoint of QR, Mn is parallel to QP, so N is the midpoint of PR. So we know that N is the midpoint of PR, therefore you can write Pn is equals to Nr. This is true. Now we have to prove that St equals to 1/3 of Ls. This one. So let us now, I am rubbing this. Now you can see these three are parallel lines. These three are parallel lines, and that we are given PS. We apply this here. PS is equals to 3RS. Now can we write PS as Pn plus Nr plus Rs? Okay. So in place of PS we write Pn plus Nr plus Rs is equals to 3Rs. Is it okay? Given PS equals to 3Rs, so PS is Pn plus Nr plus Rs. And we know that Pn equals to Nr. We have just proved it. So you can write in place of Pn Nr. So you write Nr plus Nr is equals to twice of Rs. So we have 2Nr is equals to 2 of Rs. So cancel 2 both sides. So we have Nr equals to Rs. So thereby we have already proved that Pn equals to Nr, and now we have proved that Nr equals to Rs. That means all three parts are equal. So therefore we can write Pn is equals to Nr is equals to Rs. So this side we have proved that Pn equals to Nr equals to Rs. We have to prove that St, this part St is 1/3 of Ls. So let us move on to this side. Let us look into this triangle. NMS. In triangle NMS, what we have? R is the midpoint of Sn. We have just proved R is the midpoint of Sn. At the same time, TR is parallel to Mn. So again, by the converse of the midpoint theorem, we can say that T is the midpoint of Sn. So therefore T is the midpoint of Sm. Now see, PQ or QP, Mn, TR are parallel to each other, and if these three are parallel, and if you consider this PS as the transversal, so we have Pn equals to Nr. Similarly, if we consider LS as the transversal, then we have LM equals to MT by the equal intercept theorem. Be careful what it is given. I'm talking about these three parallel lines TQ, MN and TR, and PN equals to NR. That means the intercept made by the transversal PS on these three parallel lines are equal. So any other transversal will also cut off equal intercept. That means LS will also cut off equal intercept on these three parallel lines. That means LM equals to MT. So therefore we have LM is equals to T is the midpoint of SM. So we can write here MT ST equals to TM. We can write now also LM equals to MT. Also TM is equals to ML, and this is by equal intercept theorem. So if ST equals to TM and TM equals to LM, that means all three are equal. So therefore you can write, therefore ST is equals to TM, which is equals to ML. Now let us prove the first part of the question. ST is equals to 13 LS. Above this part, what is LS? LS is LM, or you can say ST plus TM plus ML. Okay, we have the relation between ST and LS, these two. Now since ST equals to TM equals to ML, so here we can write ST plus ST plus ST. Why? Because ST equals to TM equals to ML. So we have, this is 3ST. So we have here LS equals to 3 times ST, or ST is equals to 1 by 3 LS. So the first part of the question is done. Hopefully you have understood. And now moving on to the second part of the question. RT equals to 1 by 4 of PQ. Now say that in this triangle NMS, R is the midpoint of the side NS, T is the midpoint of the side SM. So RT is parallel to MN already given. So RT is half of MN. RT is equals to half of MN. Now look at this triangle PQR. M is the midpoint, N is the midpoint. So MN is half of PQ. MN is half of PQ. So you can write half of PQ, and that is 1 by 4 PQ. So this proves the second part of the question. And the second part of the question we applied the midpoint theorem to prove it. Again I am repeating it. RT in this triangle, R is the midpoint, T is the midpoint, so RT is half of MN. In this triangle, M is the midpoint, N is the midpoint, so MN is half of PQ. So RT is half of MN and MN is half of PQ. So half of PQ is 1/4 of PQ. So this proves the second part of this question, and hence this particular question is solved. Now you can move on to the next question, that is question number 4. Before that you note it down, and then we will move on to question number 4. Once you finish, let me know that you have finished writing.
Sir, written.
Written. So moving on to question number 4. A similar type question I am writing again on the board, so that you don't have any problem in understanding the question. In the given figure, T is the midpoint of QR. T is the midpoint of QR. Side PS of triangle PQR is extended is extended to S such that R divides PS in the ratio 2:1. TV and WR are drawn parallel to PQ, Prove that T divides SU in the ratio 2:1 and WR is equals to 1/4 of PQ. So this is the question in the given figure. Now let us first draw the given figure. The triangle, we can name it as PQR. This is P, this is Q, and this is R. T is the midpoint of QR. So here we have to mark T, which is the midpoint of QR. Side PR of triangle PQR is extended to S such that R divides PS in the ratio of 2:1. So let it be S. Side PS of triangle PQR is extended to S such that R divides PS in the ratio 2:1. Now TV and WR are drawn parallel to PQ. TV, so let us join this particular. So T, this one and this particular. So TV, this is V and this is W. So TV and WR are drawn parallel to PQ. That means these three lines are parallel. This one and this one are parallel to each other according to the question. We have to prove that T divides SU in the ratio T divides S. Where is U? This is U. SU in the ratio 2:1 and that WR equals to 1/4 PQ. So how to proceed with this? Now we know that given T is the midpoint of QR. So in triangle PQR, we will move in the similar fashion. T is the midpoint. T is the midpoint of QR. Also, TV is parallel to QP. TV is parallel to QP as it is given. So therefore we have V is the midpoint of PR. Therefore V is the midpoint of PR. If you are finished writing the question, I'll just delete a part of it at the top. Now since V is the midpoint of PR and also we are given that R divides PS in the ratio of 2:1. That means given that R divides PS in the ratio 2:1, that means PR by RS is equals to 2/1. So if PR by RS is 2 by 1, so we can write, in place of PR you can write PV plus VR. So PV plus VR by RS is equals to 2 by 1. Now PV and VR are equal. Since V is the midpoint of PR, we have proved, so PV equals to VR. So we can write VR in place of PV. So VR plus VR by RS is equals to 2 by 1. So we can write twice VR is equals to twice of RS. Reducing 2 on both sides, we have VR equals to RS. So thereby we have proved that this part VR and RS are also equal. We have proved that PV equals to VR in this case. So we can write, V is the midpoint, so we write PV is equals to VR. So we have proved that PV equals to VR in the previous case here, and now we have proved that VR equals to RS. So all three are equal. So we can write therefore PV equals to VR is equals to RS. So this we have done. Now we have to look into this side. We have to prove that T divides SU in the ratio of 2:1. So moving on to this side, I am drawing this part. Let us see to the triangle TVS. In triangle TVS. So first of all, you have been dealing with this side, now you are going to deal with this side. So in triangle TVS, what is given? We know that R is the midpoint. R is the midpoint of VS or SB, right? And WR is parallel to TV according to the question. This is given. So if R is the midpoint and WR is parallel to TV, so W is the midpoint of ST. So therefore W is the midpoint of ST. This is by the converse of the midpoint theorem. We have that R is the midpoint of SB, WR parallel to TV, so W is the midpoint of ST. So this is the converse of the midpoint theorem. Now look at this again. PQ, that is QP, TV and WR are all parallel lines. And if you consider PS as the transversal, and we know that PV equals to VR, so similarly we have this equals to this. So W2 equals to TU. So we can write W is the midpoint of ST, so SW equals to SW is equals to WT, and now WT equals to TU. WT equals to TU by the equal intercept theorem. So we can write SW equals to W2 equals to TU. So all three are equal. So therefore SW is equals to WT is equals to TU. So this result we have obtained. Now finally what we have to prove is that T divides SU in the ratio of 2:1. That means you have to prove so now we find ST divided by TU. We have to prove that ST divided by TU is 2:1. That means T divides SU in the ratio of, so what is SU? Let us write SU. SU equals to SW plus WT plus TU. Right? Now what we can do here is ST by TU we have to find. So ST by TU. So what can you write for ST and TU? We can write ST as SW plus WT by TU. We can write ST as ST as SW plus WT, and this all three are equal, so you can write TU plus TU by TU. SW is equals to TU and WT is also equals to TU. So in place of SW and WT, write TU plus TU. So what we have, twice of TU by TU, TU cancels, we have 2 by 1. So we have proved that ST by TU is 2:1. So we have therefore ST is to TU is equals to 2:1. Mind it, while writing the answer, you have to write in this form, otherwise your marks will be deducted. You cannot leave the answer to this part, ST by TU equals to 2 by 1, that we have got it. No, you have to write the final answer in this format, that ST is to TU equals to 2:1 in the ratio form. Now, the second part of the question. The second part we have to prove that WR equals to 1 by 4 of PQ. This is very simple now. So the second part we have, now WR in this triangle, both are midpoints, so this is half of VT. So WR equals to half of TV, and if you consider this triangle PQR, then TV is half of PQ. So you can write TV as half of PQ. So you have 1 by 4 PQ. So therefore WR equals to 1 by 4 PQ. So the second part is also proved. So this particular part you may not include this, and there is no use, so let it, just delete this line, remove this line. So this is what is the question number 4. So hopefully you have understood, and there are many questions also in this particular chapter of midpoint theorem and converse and the intercept theorem. Do keep practicing, and that will give you more confidence. Next we will be starting or taking up a new chapter. So in the meantime, you keep solving the problems. In case of any doubt, you can put your doubts in the class, as well as you can put it in the WhatsApp group as well. So till then, have a nice day. Thank you very much.
Bye, sir. Thank
Bye.
you, sir.
Thank you, sir.
Bye bye. Bye bye.
New chapter.